Hello, my name is Buist and I'm one of the PhD students taking part in the Panorama project. My PhD is on the characterization of rare earth element interactions with iron oxide mineral surfaces. I'm located at Synchrotron SOLEIL near Paris. In this video I will introduce both myself and my PhD project. First, some of my background. I studied at Utrecht University in the Netherlands to obtain my bachelor's and master's in earth sciences. During my studies, I focused on geology, mineralogy and geochemistry, which means that I studied the composition of rocks and how they change from the scale of mountain range formation to what happens at the atomic scale. My PhD project is more focused on chemical reactions that occur at the surface instead of inside of the Earth. As part of the Panorama project, I will be looking to identify how RE interact with iron hydroxide particles. To do this, I will perform experiments in the lab, and to see if the lab results describe what happens in nature, I will also gather and analyze samples from field sites. In the lab, I am first making the iron hydroxides that will be used in the experiments. I have selected two different types of iron hydroxides: amorphous ferrihydrite, which is common in rivers, and goethite, a crystalline iron hydroxide. Aside from pure iron hydroxides, I am also making some that contain aluminium to see if that affects the adsorption. With these samples I will be doing two experiments. One to determine the effect of pH, temperature, composition and crystallinity on the adsorption of rare earth elements, and one to look at where on the samples the RE attach themselves and if that changes when the rare earth element concentration changes. In the end, the lab work will allow me to determine how changes in the different parameters affect how and when the RE adsorb on iron hydroxides. Then there is the previously mentioned fieldwork, done to check if the lab results are a good indication of what happens in nature. I will sample water, suspended particles and sediments in two different locations in Portugal, to determine how much and where the RE are adsorbed. To be 100% sure there is ferrihydrite in the samples I will take, I will be measuring the pH of the water to make sure that the pH is above 3, because at a lower pH, the ferrihydrite is dissolved. Back in the lab, I will determine the amount of RE in the water, on the suspended particles and in the sediment. In the end, the fieldwork is done to determine when and how the RE adsorb in natural systems. So why do all this work? Well, to improve our knowledge on how REs behave in nature and our ability to model this behavior. This also allows us to improve the design of mitigation procedures by using the knowledge we gain to remove RE from the environment if needed. And that's my PhD in a nutshell. Thank you for listening, and if you are interested, you can follow updates on social media noted over here.